So today what I like to do is do a demonstration of some of the monitoring tasks that we talked about earlier on. So in actually one of our first or second lessons we got in, and we actually looked at all the different things we can monitor on the device, and being able to monitor what's happening and to really use that to diagnose problems is a very, very important activity that you're going to want to do as a network administrator. In fact, I would say that probably at least half of what you do has to do with monitoring and just knowing what's happening on your network, knowing what's going on. If there's problems, you want to know about those problems early on before they become big problems. So I just want to get in and let's take a look at some of the things that we can monitor. I'm going to be logging into an operational device. This device is actually set up as a gateway. And so let's just get in and take a look at it. Obviously, I've got PuTTY up here. So we're going to be going in and taking a look at that. So let's just start with logging in. So I'm going to open up that connection. And I'm going to log in as me. All right, so there we are. Now, there's quite a few things that we did look at being able to monitor, and one of the simple things we're going to start off with is let's just monitor an interface. Let's just take a look at an interface and see what's happening there. So, what interfaces can we monitor? Well, we're going to. There we are, monitor interface, and we've got a choice of all of those, of course. Let's just do something fairly simple to begin with. Let's just do GE000. That's the one I'm currently connected to through my SSH session, so let's do that. And there we are. So we get just a one-screen view of the traffic that's going through there. We can see that those bits per second is an indication of how much traffic is going through there. Input, output packets per second, and that number under the current delta, that number is just sort of incrementing there as we view the packets that are going through. So, okay, a little bit of indication of how much traffic is going through the interface. That's, we look also seeing, are we getting any errors, input errors, drop errors, etc. If we had policing enabled, which we don't on this, but if we did, we'd see what was being discarded because of our policing. And we can just see if there's any errors going on there. So nothing very exciting to see on that particular interface. So I'm going to queue for quit. So what else can we do? Can we look at that? That's a physical interface. We can also monitor logical interfaces. So for example, let's take a look at what we've got in there. We can monitor a VLAN logical interface. Let's monitor, say, VLAN 40. And there we are. So a bit more going on with VLAN 40. But still, just a whole bunch of numbers incrementing on the screen. We can see input bytes, input packets, output packets, our traffic stats. So give us a bit of an indication of how busy that particular logical interface is. Okay, so that's all well and good. Now, What about, what else can we monitor? What if we're interested in looking at the traffic that's going through an interface? Just to have a look at what's happening with that. Might just go full screen with this. So let's do that. Let's go and monitor traffic. We can monitor traffic on an interface. So let's just do GE000. Oops. And let's have a look at that. So it's not going to be a great deal of traffic going on here. We've got spanning tree protocol, looks of it. We're racing around here. Where we've got rapids, we've got 802.1W, which, as you know, is the rapid spanning tree protocol standard. So there it is. That's what's happening on that interface. So not a great deal. I've got an SSH connection to it, but as you can see, just a lot of spanning tree traffic racing around on that interface at current. So we'll go Control C to stop that. What else can we look? Let's look at another interface that maybe have a bit more traffic going on. Let's look at VLAN 40. And here we go. So a bit more traffic going on there. A lot of ARP requests jumping around on that. A bit of TCP traffic going around on that interface. So we can sort of we can have a look at that and see what's happening. One of the things that we can do on that is we can go brief, count, extensive. Let's just do brief. We'll just take a look at that, what that looks like. We can go extensive, and we'll get a whole lot more information about everything that's going through that particular interface. So there it is, lots and lots of information. This is kind of handy if we're looking for something in particular. I could have a matching criteria there. So I look for traffic that matches something. So what are my matching options? Well, I can put anything I like there, actually. I can put an IP address. I could put some other information that I'm particularly looking for to match on, which is really quite handy. So if you're looking for traffic that's maybe going to a particular endpoint, you can put that information in there. Let's look at another interface which is of interest. So we'll go and look at traffic on our internet connection. What about that? Let's look at that one. So our internet connection is the PP0 interface. Okay, so this is our internet connection. So we're seeing we've got PPOE traffic on that. A little bit of traffic going backwards and forwards here. So again, I can use the matching criteria on this to look at some specific traffic that I may be interested in. Let's look at some other monitoring activities. So I'm going to monitor traffic, and let's go and take a look at some other options here. Let's just say I'm interested in the layer 2 headers of this traffic. So here we go. Let's do the layer 2 headers of my interface PP0. So now what I'm going to be able to see is MAC addresses. So we've got now the MAC addresses showing, and we've got packet going out from a MAC address to a MAC address. And we've got traffic coming in. So we look at our in there, and we've got it coming in from a MAC address to a local MAC address. If I just stop that there, you might notice that the source address for the packet going out and the destination address for the packet going out is actually swapped around for the packets coming in. So the destination becomes source and the source becomes the destination. Why would that be? Anybody got any ideas? There's only 2 MAC addresses, by the way. There's only 2 MAC addresses being shown. Only 2. Why is there only 2? So all the traffic is coming from one MAC address to another MAC address. Why is that on this interface? Why would that be? Any ideas? Why don't we go and take a bit of a look at that interface? So we can do a show interface, and let's do PP0. Okay, so here we have PP0. We have got the protocol encapsulation here is PPOE. Okay, PPOE. State session is up. We've got a session ID. We've got actually a session name here as well, and we have got a MAC address. Now, look at that MAC address there. That is the remote MAC address. If I go back and look at my interface traffic, and if I see out, I'll see that the destination MAC address is in fact the same as that remote MAC address. Okay, you notice that? All right. What else can we see here? Look at this statement here, LCP open. Where have you seen that before? Anybody? Where have we seen LCP open before? Anybody remember that statement at all? Nobody? No? No, completely forgotten everything that happened last term. Yep, of course. It's been a 2-week break in between. Yeah. All right. Remember when we did PPP in our CCNA course, and we wanted to verify whether our protocol was actually up and working, and we looked at the LCP. Remember that, LCP? Yeah, move it up the screen a bit. LCP. So, but this is our internet connection here I'm looking at. So why have I got LCP and NCP states right here on my internet connection? Any ideas? Why would that be there? Any clues? Any ideas maybe? Anyone? No? Well, here's a clue. Look at the encapsulation, PPPoE. Okay, so it is point-to-point protocol over Ethernet. So we are actually, in reality, running point-to-point protocol. All right, we are running that. Here's a few other clues down here with the authentication, CHAP and PAP. Sound familiar to anybody? Remember that? Oh, good. So you can see that CHAP is closed. We're not actually using that. We are, in fact, using PAP as our authentication right there. Okay, so PPPoE is really PPP. Okay, but when we did our Cisco, we were running it over a basic Cisco serial link. Now we're running it over Ethernet. Okay. So what other interesting things can we see here? Here's an interesting thing. The protocol is INET. What does that tell us? Anybody? INET means IP version 4. Okay, that tells us we're running IPv4. MTU 1492. What does that mean? Is that relevant to anything? Is that something we're interested in? Yes, we are, because I've just asked you the question, so now you're interested in it. So what is it? What is MTU, peoples? What is it? Can I have an answer? No idea. Okay, well, write this down. You're going to need to know the answer to this question. It's maximum transmission unit. Okay, that is the biggest bit of information, frame size, that you can put through that particular interface. Okay? So, why is that relevant? Well, we'll get into that. What's this information here? Underlying interface, FE007. Wonder what that means. Any ideas? Okay, what that means, let's just do a show interface. And we'll look at our interfaces. There's another monitoring command. So we've got, there we are, we've got 007. We notice that it is in fact up. All right, there it is, it's up. So here's the deal. We notice that we've got PP 0.0, which is also up. Incidentally, can you tell me what does the 0.0 signify? Any ideas? What would the 0.0 signify after the PP0? Okay, let's just drop down to the VLAN interfaces. What would the .40 signify on the VLANs? Or the 100, or the 101, or the 102 for that matter, or the 0 on the other VLAN. What does that mean? That is the logical unit number. Okay, the logical unit number. So, as you would no doubt recall, the logical unit number has to do with predominantly the layer 3 stuff, and the underlying interface has to do predominantly with the physical and layer 2 stuff. All right, so where we see PPP0, that is logical unit 0 on my PP0 interface. So PP0 interface is a logical interface which is used to provide or to encapsulate the PPoE protocol. Right, so I want you to notice we have got an IP address here. We've also got another address here, which is in fact our default gateway. So that is the other end. That is the IP address at the other end of my PPoE connection. Okay, so we're looking at PPoE. That's our local address, and that's the gateway address. That's my ISP's gateway address right there. Okay, so that's what we're looking at there. Okay, so the underlying interface is 7. So this is our logical interface. We still need a physical interface to send the traffic out of. And when we go and we see that the underlying interface is FE007, that tells us that this is the interface out of which the traffic is actually going physically. All right, let's take a look at that interface. So we'll do a show interface FE, and we'll do 7. Alrighty, so what can we see here? We see that it is up. We're going to see the MAC addresses on that. What else are we seeing here? Interestingly enough, we're seeing an MTU of 1514. What is that all about? Anyone? is different. So we've got our PP0 interface. Let's go back up and look at it. With an MTU of 1492, we have got the actual underlying interface with an MTU of 1514. Why are they different? Any ideas? Okay. Here's the deal. This is an Ethernet interface, okay? An Ethernet frame is 1500 plus 14 bytes of overhead, all right? Now, if we're looking at a Cisco device right now, we would see an MTU of 1500 because Cisco doesn't really report the overhead. They just say, well, the frame's 1500. Juniper includes the overhead of 14 bytes. So we have got, in actual fact, an Ethernet frame size of 1500 plus the 14 bytes of overhead. So really we've got our 1500, but we are encapsulating it with PPPoE over here, and PPPoE has another 8 bytes of overhead. All right, which means that the actual size that we can put through the interface is reduced by 8, which is why when we look over here, we see an MTU of, go back to there it is, 1492, 1500 minus 8, 1492. All right, so that's it there. That's where the 1492 comes from. Okay, what is that? Is that significant in any way? Yes, it actually is significant, because if we just leave everything to its own devices and we don't configure anything differently, what we'll end up doing is trying to put frames of 1500 through an interface which only has an MTU of 1492, and the result of that is that our IP packets will be fragmenting. Okay, so that's not something we want, because it makes everything go tremendously slow when they start fragmenting. And there is a way around that, which we will get to later on. We'll actually look at the solution as to how to solve that problem. In the meantime, maybe I can just throw that out as a question to the class, is how could I make sure that I don't send Ethernet packets through this particular interface that are going to fragment? How can I prevent fragmenting? In other words, how can I make that they never exceed my MTU? Just a thought for the class to think about. Okay, so have a think about that, and we will see who comes up with the answer. Automatic pass on all your exams for the future. Not really. I'm kidding. All right. All right. So what are we looking at? We're doing some monitoring here. We're looking at interfaces, checking stuff out, looking at some interesting information as to how things are configured, what's happening on here. What else can we look at? Well, one of the things we talked about the other day was trace options. Remember that? Trace options. Now, I'm just going to jump into config mode here, and we're going to look at some trace options that have been configured. I'm going to edit protocols, PPPoE. There we are. So I'm looking at my PPPoE protocol. Let's do a show under that. And we shall find that I have configured trace options under that protocol. Now, everybody see that? Here we are. Can you see that there? All right, if you look at this configuration option here, I've got trace options configured. I've got a file called PPPoE. What does that mean? That means the name of the file where I am recording this information is PPPoE. That's what I called the file. I could have called it anything. It wouldn't have mattered. I could have called it Mickey Mouse. It still would have worked. I'm really looking for absolutely everything that's happening, all levels, all events, all states, all signals, and everything that's happening with a protocol. Basically, I enabled every possible thing because I want to know what's happening. Why would I be interested, do you think, in my PPPoE protocol? Why do you think I'll be interested to find out what's happening with that protocol. Any ideas? What's that protocol doing? Any ideas? What is the purpose of that protocol? Why does it exist? It establishes my internet connection. All right? It establishes my internet connection. So yes, I'm interested in how my internet connection is going. I want to know if it drops out. I want to know if I can't establish a connection, why can't I? So let's go and take a look then. How would I look then at what's been recorded for this protocol? How would I go about looking at those events? Any ideas? I'm just going to exit out of there. Back in operational mode, I want to show the content of that file. How do I do it? It is show log, and now the name of the file, TPPOE. Right, now I'm looking at that file. So we can see that I've been logging since the 21st of December last year. The very first thing that we see is the session is down. Okay, so we see that we're getting this. These packets are coming through here. We've got pad T packets. Pad T is actually there to terminate the session. It's actually a termination packet, so it's ignored because, well, the session's already down. The process of having the session come up starts off with this discovery process here. We send this pad I because we're wanting to get some information about the session. We receive this pad O back, received that. That's the process. We want to get that back. With that, we get some information about our session. So that's our session there. We get our name, the name of our session, some information about the details of our session. We then send this pad R, say yes, we have received that. And then we get a pad S, which is session information. So once we get this, our session is up. There we are, our session is up at that point. So every time I have an entry in this log, it's because I'm really going through the process of re-establishing the session, which means that my internet connection has dropped and now I need to get it back up again. So we can see here that happened on the 21st of December at 21:33 and 6 seconds. My session was up, all happy, until 21:41 and 47 seconds, or when we lost it again. Okay, so it didn't stay up for very long, did it? We brought the session down, we sent the pad T, which is the termination. Can't send because the network's down. So in other words, we would normally say, hey, I need to terminate the session and send a pad T because I need to get the session re-established, but I actually can't even send it because I don't have a connection. So we can't send the packet. That didn't send. It's already down. We actually received one from the other end. We ignored it because the session was already down. And now we're going to start re-establishing the session all over again down here with this init pp 0.0. There we are. So away we go, yada, 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 yada. And we finally get the session up again. And which was on 21:43 and 32 seconds, but at 2200 or 22:41, basically it died again, so it didn't start for very long again. Okay, so we can see this cycle of establishing, dropping, establishing, dropping. So obviously some very bad internet conditions around that time of the year. We can go through and say we've had lots of problems on the 21st. everything worked for a few days. On the 24th, more problems. 25th, more problems. On the 1st of January, still on the 25th, more problems. 27th, 28th, 29th. So here we go. We're still finding that we're constantly dropping our connection and having to re-establish it again. Worked for a few days. 4th of January, same problems. Worked for a while. 15th of January, more problems. Worked for 5 days. 20th, couple of days. 22nd. And then it kept going till the 5th of Feb. So I can go through here and I can check every single time that I lost my internet connection. Okay, now go right down to the bottom of this file. It's February. We'll find that we'll go through, we'll get into March and so on, and we'll go through a little quicker here. There's March, April, and there we are. It has been up since the 24th of April. So today being the 22nd, it's almost a whole month. So we're going for a record here of going for a whole month without dropping an internet connection. Okay, which is, that's a bit of a record according to my log. Okay, so that information is of interest to me because I wanted to know how often my internet connection is dropping out, okay, which is quite a lot. It's also quite informative just looking at that because you can also see the process that is involved in establishing a PPOE connection as well. I mean, it's quite informative. You can see there, here's the process. We start off with the discovery. We're getting some information. We're sending this pad I. We come back with a pad O. We send out our pad R, and we receive back a pad S. Okay, which says here's the session. The session is up. All is good. Okay, so that is also the process there. All right, so there we are. That is a that is a trace option on that particular protocol. Okay. Of course, if we're looking at a different protocol, we'd have different information that we'd be seeing there. Okay, so that is something that is of interest. There's various things that you may want to monitor on your network. That's just one of them, but you could set up trace options on other protocols as well, and just collect information, right? So it's good. You can go back to it. You can look at it. Now, what's another thing I can look at here? Any ideas? What's a standard file where we always collect stuff? What about our syslog file? Where's that? What's that called? Any ideas? No? Okay. Show log. What's it called? Anybody? Messages. There's going to be a lot of stuff in that. That's my syslog. Okay, so lots of stuff in there. I can see that I've got a problem here. That one of the issues I'm having is that I'm actually exceeding my CPU thresholds for some processes. That kind of tells me that what's happening is I'm overloading actually my CPU on my device. So I might be thinking, well, I wonder if that's still happening, because I can see that I've got it here on the 22nd of May, so maybe it's an ongoing problem. What if I wanted to monitor that in real time? Can I do that? Yes, I can. That would be monitor. And what I get to do here is I'm going to go start. Oops. Monitor start. And what am I going to actually monitor? There's lots of things I can monitor here, but if I go down, look on the list, one of them is my messages. There it is there. This is my current syslog file. So let's monitor that. Oops. Messages. Okay, so now what is going to happen now is if I'm continuing to do this, that's going to be displayed on the screen. So there it is, coming up live on my screen. the fact that I am exceeding this particular CPU threshold. Okay, so I can tell that there's some process on my gateway right now that's actually exceeding my CPU, that's causing this particular stress on my CPU, and I'd be kind of interested to find out what's doing that, what's happening, how come that's happening. What I might do, what I could do, this is one of the advantages of sort of this monitoring. I can have that there. I can just kind of see what's going on with it. But at the same time, I'll actually start up another. Oops, just trying to adjust this on the screen. I'll start up another party session. Open that one up. Okay, by the way, you can see that's me logging in there. Went into my syslog file. So let's just get this up on the screen a little bit. Yeah. Just adjust the size of it. So what I might do is take a look for any obvious stresses on my router. I can do a show chassis routing engine, so I can pull that up. To be honest with you, it doesn't look overly stressed because it's idle 80% of the time. So it's even more curious as to why I'm getting this particular threshold exceeded, because I'm not really working the device all that hard. So another thing I can monitor is show system processes, and I'll get an extensive output of that. And we can see that this particular process is probably making the router work harder. The fact that it's over 100% is not an unusual thing. It's not that doesn't mean that there's something wrong. It's not unusual to have a process going well over 100%, and it's still quite normal. So that's not telling me anything particularly interesting at this stage. So I'd have to really get in and do a little bit more investigation as to why that's happening. There's something that's kind of hitting it and just exceeding a threshold there. So the beauty of it is I can sort of look at these things together. I can have this running. I can be down here doing other things. I can be down here configuring something, changing the configuration, committing the configuration, and still monitoring at the same time to see the effects of of what I'm configuring. So you kind of handy. You can have one or more screens up and monitor in real time the effects of the changes that you might be making. Okay, so we're looking at monitoring. Okay, looking at monitoring. Lots of different stuff we can monitor. All right. So I think we'll stop it there.